I'm Jason Hayes. I'm product manager here at Trimble with the oil, gas, and chemical division, and I've got a lot of experience with Trimble RealWorks, and so I'd like to share a little bit of that with you today. So the main points with this presentation is going to be generating deliverables from 3D point cloud data with Trimble RealWorks. I'm going to lead you basically through a workflow of a small project going through and creating some deliverables. I would start out with registration and then go through into the different modes of Trimble RealWorks to finally get something created. Got a lot to talk about, so I'll talk pretty fast. It's meant to be kind of an overview just to see what's available and the capabilities of RealWorks. If you have any questions, go ahead and type them into the chat, and I'll try to keep an eye on the questions coming in there. There'll also be some time at the end of the presentation for questions. And you'll also see my email address on the screen. So if you don't get your question in today, feel free to email me, and then I will do my best to get you an answer to any questions that you might have. So I'm going to go ahead and get started. And what I've got is a video I recorded, mainly so I could highlight the cursor and things like going through the registration process happen quickly as opposed to having to wait for all of the processing. So I'm going to go ahead and get started with registration. So basically, this has a project that I've done with a TX5. I've gone out and scanned some stations inside and outside of the building. Here I'm just going to go through and register the inside scans of the inside stations. And I've added color with these using the TX5. So the workflow I've used is I've opened the project from the SD card from the TX5 in Scene. I've applied the color in there, saved the project, which then moves all of the colorized FLS files into one folder called Revisions. Then from RealWorks, I'll go in and open a project. I'll browse to the folder where those FLS files are stored, select all of those, and then they'll come in and be converted to TZF files, which is the native RealWorks file format. So on my screen here, you'll see that I'm selecting the stations. And the next thing I'm going to do is go to the registration menu. I'm in the registration mode here, so I have all of the registration tools available to me in the menu. The way RealWorks is laid out is kind of the way you would go through a standard workflow. So the first thing I would do is use the auto extract targets and register in this case. So once I select that tool, it opens up the dialog box, and in here I have the option to choose a target type, either a spherical or a black and white target. I have the option to define the size for that target. In this case, I was using the standard 139 millimeter spheres that ship with the TX5. And I've also got the option to generate a preview scan. So when I bring these FLS files in, convert them to TZF, there's actually no points in the project yet. So with creating these previews will create kind of a decimated point cloud that allow me to look at my registration and make sure that it's good. And then from there, I'll show you some more tools for actually loading up all of the points into RealWorks. So in this case, I've selected spherical target. I haven't chose black and white target because I didn't have any black and white targets, and I don't want the software to spend time looking for something that's not there. You'll see that my units are set to survey feet. However, I can go ahead and enter in millimeters, and it'll go ahead and convert those for me. Generating preview scan, reference station. Generally, if I've got a leveled station, I'll choose that as my reference, or I'll try to find a station that connects to most of the other stations. So you see it's going through and extracting all of the targets now. Once it's extracted all of the targets, it'll go through and create those sample scans for each of the stations. See, in this case, there's 7 stations, so it's going through now creating all of those sample scans so I can see the point cloud. Okay. Once the auto extraction of targets is done and then the registration, I'll get any warnings that might pop up. In this case, it's letting me know that one of my stations didn't register, and it's asking if I want to ignore it. That's fine. I can go in and fix that with a couple of our other tools. So my target matching succeeded. I can look through here. I've got actually really good residuals. It's because I'm set to survey feet. And I change my preferences. I could either change to millimeters or just of my decimal places. Okay, so now I can scroll through here, look for my residual error. I'm really looking for anything large that might stand out that could be a problem, but overall it looks pretty good, with the exception of missing that station number 4. So what I'm going to do is open the Target Analyzer tool. And what this tool does is it allows me to go in and look at each of the stations and all of the targets within those stations and analyze the targets. And if needed, I can go in and create or delete potentially bad targets. So in this case, I'm going to select a station. Station 4 was the one that gave me some trouble, so I'm going to just pick the station before it, station number 3. I know the order of my scans. I'm just quickly going to look through these targets here. You see that the screen's split into 2 views. I've got a 2.5D view and also a 3D view. So the 2.5D view is just a lot easier to see my scan. It's a lot like looking at a picture. In fact, it is a picture. And then the 3D view lets me go in and rotate around in 3D to really analyze and make sure things are fitting the way they're supposed to. So I'm quickly going through and just looking at the targets and making sure that the targets it has extracted are correct and that it didn't pick something like a baseball or a softball and create a target on there. Just going to tile my windows vertically because I like the way it looks better. Okay, now on station 3, I see that there's a target that didn't get corrected. I was just browsing around through the 2.5D view, and I see a target hasn't been created, so I want to do that. So over in my workspace, you can see there's step 3, the option to extract and create targets. Once I click that, it opens my Target Creator tool, which allows me to choose what kind of target I would like to create. I can create either a spherical target, a black and white target, or I could, in fact, just click on a point that's easily identifiable from different stations and use that as a target. So in this case, I'm going to choose a spherical target. I'm going to leave the diameter set at 139 millimeters. And I'm going to use the one-click extract. I could, in fact, fence around an area and try to extract a target from there, but the one-click extract works very well. Okay. The one time that I probably wouldn't use the one-click extract is maybe if I'm using a black and white target that's attached to a wall that's at a poor incidence angle to my scanner. So I'm not looking at it perpendicular, but kind of at a skew, and it makes it a little bit difficult for the software to tell what it is. In that case, I would probably fence around the target and then create it as opposed to using the one-click extract. In this case with spheres, a one-click extract works very well. So I've created that target now. That might have been all that's needed, but I'm going to go ahead and look at station number 4, check each of those targets that have been created, make sure that they're correct, and then I'm going to browse around and see if there's any targets that might have got missed by the software. So there's one out here on the stairway coming into this building, and I can see why it was missed. It's partly obscured behind some iron. I'll go ahead and create that. And I'll just take a quick look at station 5, which I know is right next to station number 4. I'm going to do the same thing, look around, see if there's any targets that missed or look bad. Overall, it looks pretty good. So I'm going to go ahead and click Adjust. It's letting me know that some targets have been created or modified and wants to know if I want to do an auto match for these stations. In this case, I'm going to say yes. I could do it later, but that's the whole point of doing this, is to match them up. So I'm going to go ahead and say yes. And now I've got a new registration details. So I can quickly see now that scan 3, scan 4, scan 5, it's now matched the station that wasn't there before. The residuals are still looking good. Just quickly scroll through to make sure nothing else has changed. Okay, so my numbers are looking good. As always, though, I want to go through, after I apply this, and do a visual inspection. I'm just applying. Now I want to look at this in the 3D view, and that's why I created those preview scans. So right away I can see 2 spheres that are on top of each other, matching up very well on the geometry. I'm just going to change my cloud rendering to station color so that I can see the color of each station stand out alone. So in this case on the sphere I can already see 3 or 4 colors. I see some orange and some red, some purple, and some gray, and I like the way those are coming together. So that's a good sign, at least in that specific spot. And then I'll zoom out and take a look at the whole project and make sure that it's coming together correctly. It could just happen by chance that you may have some spheres that just happen to have the same geometry to them, so that it could in fact register incorrectly. That's why it's always good to come through and do a double check visually just to make sure that everything's okay. I can display my stations, and I can display the label, so I see the station name and see where they fall in respect to the point cloud. I can also right-click and bring up the network visuals. I can bring it up for just one station or all of the stations. Then I can see the station and all of its connections to all of its targets. So again, I'm just rotating around, taking a look at this, making sure that it looks like everything is coming together the way that I want. Because I colorize this using the scene software, I can use the rendering of true color to see the point cloud displayed in true color. Okay, looks pretty good. All right, so the next thing I want to take a look at, my registration looks good, is I may want to orient this project so that it's easier to work with. If I was using maybe a survey coordinate system already, I would just skip this step and leave it in the coordinate system that it was. In this case, I just took the scanner out. I didn't bother setting it up in any kind of a coordinate system. So for working in the point cloud, I'm going to go ahead and do a quick orientation. It's a new tool in version 7.2. You can see here that if I use my top view, this view is kind of skewed according to my screen. I would like it to be square with my screen so that when I use these different views, it'll jump to a nice straight top or front or side view. Okay, something like that. So I'm going to go to Registration, choose the Orientation tool. I have a couple options. I can define my orientation by picking two horizontal points, or I can let the software automatically try to detect this. Works sometimes, sometimes it doesn't. Or I can pick a new origin as well. In this case, I'm just going to pick 2 points along this side of the building. Looks good to me. Go ahead and validate it. And what that message was telling me is that it's now changing my home coordinate system. If you're familiar with RealWorks, you can have more than one coordinate system. You've always got your home, and then you can create working frames with some of the additional tools. In this case, it's not creating a working frame or a temporary frame, so to speak. It is, in fact, changing your home coordinate system. And so it gives you that warning in case maybe you had set up on survey coordinates, and it's letting you know that it's going to change that now. Okay, so now my views are working nicely, top, front, back, and this just makes it a lot nicer to be able to use these quick views now if I want to go in and use some of the segmentation tools like the rectangular segmentation, or if I'm in fact modeling to be able to view these objects straight on. Next thing that I'm going to do is I'm going to generate a key plan. Key plan will come into play once I talk about the Scan Explorer tool, which I'll show you here shortly. But in following the workflow, this would be the next thing that I would typically do. So to generate a key plan, I'm just going to view the point cloud as I would like to see maybe the whole project later on. I can display these however I have the point cloud displayed on the screen. So I can look at this object from the top, I can look at it from the sides, and where this might come in is if I had a multi-story building, I could create a key plan of looking at it from the side, and then later on in Scan Explorer, this will make more sense once I show you, I could then segment out individual floors using this. In this case, I'm just creating the key plan of a straight down view. And maybe I do need to geo-reference this. Maybe using just that quick orientation isn't good enough. I would skip that step and I would go straight to geo-referencing. Geo-referencing allows me to bring in survey coordinates, control file, and then match my targets up to those. So here I'm just showing you a simple control file that I have. These aren't real particular coordinates. I just took these off of Google Earth because I didn't bother to take my GPS with me when I did the scan. But anyway, I've got northeast elevation and a name of my target. So going to open, I'm going to choose Survey Network File as my file type. and then browse to that control file. And it's just a text file. Once I do that, it's going to open my survey network dialog box. And here, down at the bottom, you'll see that there's a preview showing the point name, northing, easting, just the way that it's going to be imported. And right away, I can see that this doesn't look right. It's got some blank lines. So I've got the option to go up here to the header, tell it not to skip any lines. It's starting to look better. And I can choose my separator. In this case, I'm going to use tabulation. Once I've done that, I see the preview is looking really good now. I just want to make sure that my file format's correct. If not, my points are going to come in either backwards, or if I have the wrong units, they're going to be stretched and things are not going to match up. So in this case, it is northeast elevation and meter. And you'll see now that the survey network file has been imported. So now I'm going to go to the registration menu. You saw that I selected the main project there, and I'm going to the Geo-referencing tool. Now the Geo-referencing tool, this is showing all of my targets in the project. When we did the auto-extract part, the very first step, these were all of the targets that were auto-extracted. Now I know which targets match up because I've looked at this project a little bit. So I'm going to go through here and select the targets. And if I click on my target, I can go ahead and select that and then match it up to a point in that control file. I could, in fact, use that other option by picking to maybe pick a corner of a building or something if I knew coordinates for that. In this case, I'm going to just browse through the list and select the target. Another option I could have is I could simply just type in the coordinate values if I hadn't imported my control file already. In this case, since I imported the file, I'm able to just go through and select these and match them up. Okay, and you'll see it's displaying the error over on the side. As I start to add more than one target, you'll see the error between the points that I've imported versus the targets that I've selected. Again, these targets were just brought in from Google Earth, and so the error is pretty high. It's almost a foot in this case. However, using survey quality coordinates, you would get something much smaller in your error. Okay, so I've got my 3 targets brought in. Just going to click on Display Errors. And I'm going to zoom in on my project so I can see this. One thing I'll mention, don't be alarmed sometimes when you bring in control files because their coordinates are going to be a lot different probably than what your scanner's default coordinate system is. So you may look like you have 2 completely different projects, which in essence you do. You've got your control coordinates way over here and your scanner coordinates that are way over there. So until you get these matched up, they're going to be kind of far away from each other in RealWorks. I'm just going to zoom in now. I'm going to turn off the station names. And I can already see my 3 points that I've matched up, but I'm going to hide my point cloud. And maybe you'll skip past that pretty quick. But anyway, I can zoom in then and visually verify that my matches are good. So I'm all finished with registration now. I've brought my points in, all of my scans. I've registered them to each other. I've either created a quick coordinate system, or I've gone through and done some geo-referencing, or the third option, you could just in fact work with the coordinate system that came in directly from your scanner. Next thing, now I'm going to change my mode from registration to office survey. Okay, so switching to office survey. So now the points that I've got in here, my main project cloud, up in the upper right in my list window, you can see that it's only got about 2 million points. So those are the previews that were generated when we did the auto extract and register. So what I'm going to do now is open Scan Explorer. It's a new tool that we've added in 7.2. Just wanting me to save my project real quick. When I open the Scan Explorer, you'll see that it's got what we call a 2.5D view, which is your main screen that you can rotate around in, zoom in, and zoom out. It's a lot like the station-based view that you would use in the main Trimble RealWorks. And on the left is all of my stations in the list window. So I can select a station either from the list window or by clicking on the orange triangles. And I can also change the view. Two options. We've got grayscale, which is kind of the default. And if you've got color from your instrument, perhaps you use a CX or a TX5, you'll be able to see the images here as well. I can toggle on and off station-based icons. You can see here I can just change through my stations by double-clicking on the station. And I can rotate around, zoom, view up and down. Okay. We've got a simple measurement tool in here, allows us to take measurements. We've got three options. We can take a distance to distance, a vertical distance, or along a horizontal path, or in fact just a single point. In this case, I'm going to take a vertical distance measurement just from the ceiling, and I can click anywhere on the ground, and it will go ahead and find the point directly below that according to the Z azimuth in your axis in your coordinate system. Take horizontal measurements, again, based on your coordinate system. And I can take just the distance to distance measurement as well. All of these measurements that I take, I can add those to the list window in the main Trimble RealWorks screen just by clicking Create. And what I've done here is I'm just toggling between the two screens. I'm going to pop this open, I just noticed. Scan Explorer opens in its own main window. The benefit of that is that you can have it on a separate monitor if you like, so you're doing all of your segmentation and selection of points using that, and then be able to view the results on another monitor with Trimble RealWorks. If you don't have two monitors, I just minimize and maximize the two, and it works pretty well. So you see here I've got my three measurements that I brought in from Scan Explorer. And here's the key plan that we created earlier. Key plan allows us to see the whole project. In this case, I created my key plan from the top-down view. I can create more than one key plan, and in fact, and it'll show up on the left in the list window just like the stations did. So I can create custom key plans based on different floors or different areas of the project, however I please. And in addition to taking measurements, we also have the ability to extract points using Scan Explorer. This is one of the primary features in Scan Explorer. In this case, I can use a rectangular option or a bounding box if I know the elevations that I want to select between. In this case, I'm just going to use a rectangular and select a slice out of my point cloud. I have the option to remove coincident points, points on top of each other, or sample the point cloud down. So the progress bar on the right letting me know as it was extracting the points. So here in the main RealWorks view, we see the slice of point cloud that I just created. Just going to change the pixel size a little bit. So now I can zoom in and do some detailed analysis just on this one area without having the clutter of the entire project point cloud being in my way. Okay. I can also extract points from our station-based view as well. I've got a few options here. I can do the rectangular area like we just saw using the key plan. I can select the polygonal area if you're familiar with that in RealWorks. Another option, we can extract just a cubic area. We can extract the whole station, or in fact, a cutting plane similar to what I just did with the key plan. In this case, I'm just going to show you the cubic area. I've got an option here to include all stations. It's very powerful. We're looking at this view from one station, but when we select the object of interest, we can in fact grab the points from all of the stations, which makes it very nice. In this case, I'm just going to click on the sphere. Using the cubic option is really nice if you've got a lot of objects that are the same size, same shape, that you can go through and quickly just use this option to click on them and extract them out to Trimble RealWorks. With the cubic, I define a half depth, basically how big I want that cube to be based on the object, and then extract. Polygonal area, just going to segment around these pews or benches. And you see I've got the option to include all stations, remove coincident points, or sample it down if I would like. I'm just going to extract RealWorks. Again, the progress bar in the lower right. Once the points are all extracted, it'll show up on the left at the bottom and tell you how many were finally extracted. 4 million points. Now, let me just hide some of these objects that we extracted previously. So now you can see the area that I extracted. Just going to center on point real quick so my rotation centers on that. And now you see it's extracted just the area of the benches that I fenced around using the polygonal option. Now one problem you'll notice also grabbed a lot of points outside, which I don't really need those. We've got a way to deal with that. If we use the rectangular option, we can in fact do something similar to what we did with the cubic option, that we select an area, and then we can go in and specify a half depth. In this case, I'm using something like 3 meters. And then I'll click on a point inside my rectangle and use that as my center point for my half depth. So now I'll be extracting points 3 meters either side of that. One other thing, we don't always have to send points just to RealWorks. We can in fact click on that arrow and export to E57, LAS, or an ASCII file format as well. So that's where it's beneficial to be able to sample down your points. Maybe you're sending them to another software that's not made for handling points, so you may only want to send out a few thousand points as opposed to a few million. In this case, sending them to RealWorks. My progress bar on the lower right, you see that it's up to about 7 million points, 8, 9. All right, so in total I extracted 10 million points. If I look at RealWorks now, you can see that this object now has just grabbed that area of the building and not what's outside. So you can see this would be very useful if you're extracting points on a large project, maybe a building, and you just want to get the points in one room, not the entire building in that 3D. If I select whole station, it's going to extract the whole station, just like it says. And if I have the option include all stations selected, it will then in fact export the whole project. Okay, so that's Scan Explore. Next thing we'll take a look at now is getting into using some of the tools in RealWorks to create deliverables. We'll start with segmentation, sampling, and creating some contours. So in this case, this is a church or a chapel that we've scanned, and we want to create some contours on the topography around here. So the first thing we need to do is get rid of some of the items in the project that we don't need to create contours on. So we're going to quickly just segment around the building to remove that. And with RealWorks, when we use the segmentation tool, we have the option to use polygonal segmentation, rectangular, or circular segmentation. In this case, I'm using the polygonal option. I'm fencing around the area, and then I have the option to either keep that in or take it out. In this case, I'm going to take it out and remove it because that's not something that I want to create contours on. I'm just going to create the point cloud that was left. And then the next thing that I want to do is get rid of all of these trees, power lines, fence posts, things like this that I don't want in my contours. So to do that, I'm opening the sampling tool. And in the sampling tool, I have a few options for sampling or removing points. I can randomly remove points just to reduce the size of the point cloud. I can use a spatial sampling if I want to reduce the number of points and have kind of an even spacing between them. I can use a scan-based sampling. This would be if I wanted to remove certain stations and not see those. I can use an intensity-based, or discontinuity, or topography-based. In this case, I'm going to choose the topography-based. And you can see there's the initial points and the remaining points. What I want to do with the topography-based tool So it allows me to create a horizontal radius. So it's basically building these small cubes. It's going to go through and look for points that kind of deviate from the standard around them. It's a little easier to show than to explain. I just wanted to make the point that it's not truly an elevation-based sampling. So I'm not just simply starting at the top and cutting out points, because in that case, you see, I would start to cut out hills and things like that. So in here, I'm just going to leave the horizontal radius at 200 millimeters. Just changing my cloud rendering so I can see a little bit better. And then I'm going to move a vertical filter along. Now, this plane is going to move vertically. It's going to go down. However, it's just a selection area. And so it's not, in fact, going to just cut out the points, like I said, based on elevation. So it's working a little bit smarter than that. So I'm zooming in. It's highlighting in red everything that it's selected before. So you see it's grabbing some trees, some of the people standing on the side of the road, power lines. Move it a little bit farther along. And now you see it's highlighted a lot more of the brush along the ground, the fence posts around the parking lot, and it's just erasing that so it clears it out a little bit. I'm still in the tool, so I can keep on applying it. Basically resets. I'll move the slider over to the left a bit. Okay, it's highlighted a few more. I zoom in, I can see that it's not completely picking up all of these fence posts or tree trunks. So I'm going to move it a little bit more, paying attention to what it highlights. Okay, so it's picked up those, but it's picked up a lot of other areas. So I might back it off just a little bit. Now with this tool, it's okay to sacrifice a few points because there's still plenty of other points left to create these contours from. So this looks good, and it was much faster than having to go through and manually segment out all of these trees, brush, and fence posts, power lines, things like that. So now I've got it cleaned up pretty good. I'm going to open my contouring tool with the remaining point cloud. By default, its parameters are from the lowest point to the highest point. I can change that if I want. In this case, I'm going to leave it. Set an interval. In this case, it's set to 1 meter. Go ahead and change that if we want to, half a meter. And before I go, I'm going to sample this down even more using random sampling because I don't need 36 million points to create my contours. It'll just take longer for the software to process. Okay, so I've sampled it down. You can see the number of contours it's going to create is 21. Looks pretty good. In the 3D view at the top, I see the lines and the point clouds that have been associated with them. I can define principal contours, which will go in and attach elevation labels to each of the contour lines. Okay, so it's looking pretty good. Display my church on top. Okay, so that's one scenario. Next tool I'd like to show you is the cutting plane tool. Cutting plane tool is a very powerful tool for going in and cutting out slices of your point cloud to either do analysis, line work. It's great actually for analyzing your registration. In this case, I want to do some work on these windows. So I've already segmented them out. Now I want to create a slice through here. So for instance, maybe we want to know just how thick the walls are, the stones that make up the walls of this building. So in this case, I can orient my point cloud and my cutting plane. In this case, I'm just going to orient it perpendicular to the z-axis. I've got various methods for orienting this. And I can move it along. I can define a single slice, multiple slices, and I can also put in a thickness. So if there's not a lot of points in the area, I may want to increase the thickness or even increase the pixel size so I can see a lot better. And then I can come in and either take some measurements here, or I can in fact create this point cloud slice for later use or exporting to another software if I'd like to. So you can see pretty thick stones, almost 1.5 feet thick on this building. You see here I'm using my quick views based on my quick orientation that I made earlier. Now I want to create some line work based on these windows. So I've created my plane so it's oriented to slice directly through this area where the glass is, and I can move it back and forth just until I get a perfect outline of these windows. Okay, looking pretty good. You can see the frames holding the glass. So I've gone ahead and created that, and now that slice has been added in my list window. Now with this slice, I can orient it different ways. I can go and clean it up using my segmentation tool if I wanted to. Perhaps I want to get rid of some of the points that showed up on the glass if I wanted to. Or I could, in fact, just export this out and do line work maybe in another software. If you're an AutoCAD user, you can export these out. I would recommend using the LAS format. It allows AutoCAD in newer versions to convert it to their own PCG format, which is optimized for point cloud. I export this out. Got the option of my reference frame. Okay. Once I export that out, to open that in AutoCAD, I'm just going to click Insert. This is AutoCAD 2012 that I'm using. Choose Index, browse to that LAS file, and it's going to go ahead and convert that to a PCG. Once it's done with the indexing, go ahead and open that out. Okay, once that comes in, then I just want to zoom in on it so I can see it. Change my view. I'm going to go ahead and change to the free orbit so you can see how easily this rotates around. So I don't remember how many points were in there, but generally AutoCAD hasn't been great at working with points. You can see that it's using it quite smoothly once it indexes it and converts it. However, we don't have to use AutoCAD. We can do our line drawing right in RealWorks if we like, using the polyline drawing tool. In this case, I'm just going to create a plane to draw on. I could draw straight on the points, but I prefer to have a plane, so my line works all on one nice plane. I'm just picking 3 points to define that. Okay. And I can go in and simply just start to draw. I've got a few options. I can draw lines, rectangles, curves. Okay, I'm just using shortcut keys to switch to curves or arcs. And back to my straight lines. Just going to right click, choose to close this line, and create that. And you'll see the line now showed up over as Object 521 in my list window. Draw these other 2 windows. Now these are different size than the one that I just did. I'm going to do something similar. Line, switch to an arc. And you see that arc didn't fit just exactly. I can come back and move that before I create the line. I'm just clicking. So I'm not going to create it right now. Let me come up here and just move this arc a little bit so it matches up. Okay, that looks good. I can go ahead and create that. Now the window on the far right, it's pretty much the same size. So another option I have is I can copy this line and just move it over to the other one. So you can imagine if I had maybe 30 or 40 of these windows that were all the same shape and size, rather than draw each one, it might be a big time saver to use this copy selection and create. So it basically makes a copy of that, which you can then move over to the next one. I think it was Control D is the shortcut key for that, so I could just simply keep moving into place, use the shortcut key Control D, move the new one to the next one, Control D, move, and so on and so forth. So I've created now my line work. I can take this and export this out to any format that I might need. In this case, maybe I'll choose a DXF or a DWG. Okay. And it gives you some export options here. I can choose the cloud and the geometry. In this case, I just want to send the geometry. And the clouds would be just the points that were used right around those lines. So that's the cutting plane and doing some polyline drawing tool. Now, there's a lot more to the drawing tools than what I showed you, but again, just trying to give you an overview of what's possible. Next tool that I'd like to show you is the inspection map. Another very powerful tool in RealWorks that allows you to go in and compare 2 different surfaces. It might be a design model compared to an as-built point cloud, or it could in fact be 2 point clouds to each other. Maybe you scan one day, there's been some work going on, so you want to scan another day and see if there's been any deformation or movement. In this case, I've got a design for a tunnel and in the point cloud. I'm going to select both of these tools, both of these objects, and then in the office survey, anytime I've got 2 or more objects selected, I'll have the option to go in and use the Twin Surface Inspection Tool or the Surface to Model Inspection Tool. In this case, I'm going to use the Twin Surface Inspection Tool. And basically what we're going to do is create an inspection map, a 2D map, and it's going to be colored based on the differences between these 2 options. So in this case, I need to define a projection. I'm going to use a cylinder, very similar to maybe a transverse projection you might use. Okay, I've defined this. Then I define resolution, how big of a spacing I want when I create this inspection map. And I don't want to choose a resolution that's smaller than my point cloud, because then I'll have a lot of big black holes or gaps, because it's trying to create something where there isn't a point to compare to the design. So in this case, I've set my resolution. I'm going to do a preview. Around the outer edges here, you can see a little bit of those black lines that I was talking about. I can go in and try to fill those in using some interpolation if I wanted to. In this case, I'm just going to leave it as is. And on the right, you see a color bar. So I'm just going to edit my color bar. I have the option in here to set certain intervals. I could, in fact, change the coloring. Maybe I wouldn't be worried about anything more than a half a foot. And so anything less than a half a foot, I would just leave it maybe yellow or green. And anything over a half a foot, I would make it all red, because it's all important. So you can define that however you like. In this case, I'm just going to set the intervals. Now I could create this inspection map, it's finished, or I can go straight into the inspection map analyzer. So in this case, in the inspection map analyzer, it gives us some tools now to go in and to draw some information out of this map. Got a few options. I've got points and polylines, colored mesh, sections and shifts, volumes and surfaces, and ISO curves. In this case, I'm going to take a quick look at the sections and shifts. So you can see I'm moving these handles along on the inspection map viewer, kind of here in the middle of the screen. And over on the right, I've got the section viewer, which shows the cross-section, the slice that line's going through on the map. And below that, I've got the difference plot, which is going to show me the red line, the reference surface, the green line as the comparison surface, and graph these two, and then the table around the outside is going to show the position on the map and how much the two are differing. So as I move that along, you can see that in this blue area, it's pretty extreme, it's getting out there, it's 4, almost 5 feet, that my graph, my difference plot, you can see the green is taking way off from the red. And you can see also in the section view right there, the blue over on the kind of the left side is really sticking out. Okay, so as I move along here, you can see how the difference plot changes. So I'll move it to this area, kind of see down in the sides here that we've got a little deviation from our design. Now the section viewer, I can also display the point cloud, and I can unlock it from 2D, so I can see exactly where this is falling in my point cloud. It makes for a very powerful visualization. Okay, I could create those sections and shifts if I wanted to. In this case, I'm going to just switch over to colored mesh. And what this is going to do is create a mesh of a surface, either the reference surface or the comparison surface, and then texture that mesh using the inspection map itself. So in this case, I chose the comparison surface, clicking on preview. So now it's basically created that mesh of my points and textured it with that inspection map. So again, it makes for a very powerful visual, which you can take and if you wanted to make movies or export it to another software, makes a good presentation. So now I've got my inspection map, or my mesh displayed, so I can see it over my section viewer. Another option is I've got the points and polylines. So maybe you need to go in and do something with this data. You got it. Now you might need to find where the area of interest is, get coordinates for it so you can have somebody navigate to it. In this case, I'm using a polyline just to highlight it around a certain area that's important. I can select to either have this on the reference or the comparison surface. You see here as I rotate around, just kind of give you a quick view of the map a little bit there. Okay, so you see it showing up there on the comparison surface, highlighting that area that's got some problems. I can create that as a polyline, which I can then export out. And I can also take individual measurements. So right here, maybe I need to navigate with a total station or something and point out this area. So this is area we need to add some more fill here, or you dug too much and we're not going to pay you and show you in the field where exactly it is. So I can create that individual point and have the coordinates on that as well. Going back real quick, look at the sections and shifts. And go ahead and create those just to show you how they show up in the RealWorks once the tool is finished. So you can see here I've highlighted just the 3 objects that are created when I create these sections and shifts. Close this real quick. So if I hide some of these other objects, you can see when I create my sections and shifts, it's made 3 objects. I'm going to have the red reference line, the green comparison line, and then also the visual lines in between showing us the difference between the two. So again, you can export any one of these lines or all of them as you need. Do screen captures to put into reports, take measurements between them using the measurement tool. Okay. Just displaying the properties of that individual point that I had extracted earlier. You can see the coordinates there. Okay. Give you one example of using this tool. This is an underground mine that was scanned, and the question was asked if these beams here, these support beams, were built throughout the mine. This is a very old mine, almost 100 years old, and it's been closed for a long time, and it's being reactivated now. So they're going in and building it up to the new safety standards. And if they were to go in and build these support columns to hold it up, how much work is going to need to be done farther down in the mine to do this? So what I've done is created a model of this, the support beams. This is an inspection map that I created and textured earlier. And so I'm just going to compare. You can see the dark blues can coincide with the corners of this building where more material is going to be removed. Just switching over sections and shifts really quickly to show you as I move along here. You can see the difference between the model and the scan of the point cloud here, and you can see just exactly, very strongly, how much material needs to be moved in order to put this in. So you can see just a cross section there, and again I can move that along here, see the differences, different areas that are going to be trouble or need more material moved. Maybe blasting is going to be involved in some spots. I can pinpoint those. I might need to know how much material needs to be taken out of here. So I could, in fact, go in and maybe not just create that simple model, but create an extrusion to go along a section of the tunnel, and then compare that shape to the tunnel itself to know exactly how much material is going to need to be removed. In this case, I'm just drawing around a certain spot, but you can see as I segment around different areas, it'll give me a volume, or I can select by different colors right on the point or the inspection map itself. So you exactly know how much material is in that area of the color bar. Okay. Let's go ahead and create those. Okay. if you did a volume report, you could maybe take the screen snaps or export out these geometries to add to that as well. Another example, taking a look here, I've got 10 minutes left, is a storage tank. So in this case, we've got a storage tank and we've got a retaining wall built around it. So this is built in case there was a leak in the tank to make sure that the product would be contained within this secondary containment of this retaining wall. So what we want to do in this example is make sure that it's going to contain what it needs to. So we're going to calculate the volume of this retaining wall. So the first thing I'm going to do is go in and I want to create a model of my tank. Mainly just doing this so I can extract it from my volume earlier. So I'm modeling it. I'm using a constraint to make it perpendicular to my z-axis. Okay. Going ahead and creating the model. Very quickly, just fit a cylinder to this tank. Next thing I want to do is I'm going to want to go in and create a mesh of this retaining wall that's surrounding it. So I'm going to select the point cloud, minus the tank, obviously. Sample it down, because I don't need millions of points to create a mesh. It just creates extra triangles that computers have to worry about. So I'm segmenting around just my area of my mesh, or my area of my retaining wall that I'm interested in. And create that, do some quick editing to smooth out, get rid of the rough edges on this mesh. Maybe there's some tumbleweeds growing or something. It'll smooth those out. Changing the color so it's just easier for me to see. And I'm going to use the geometry creator now to create a plane. And what I'm going to use this plane for is a reference to know where the spill point would be on this retaining wall. I'm just making it another color, changing the size to fit my area. I just tried to use a contrasting color. Now I'm using the geometry modifier to just move this plane up and down according to the z-axis, and visually just looking to see, okay, where is the lowest point of this retaining wall? Where would the product start to spill out? Just move it until I see the area. And then using my measurement tool, I'm just going to go and create a point so I know where that is later at that area. Okay, so now I've got a plane. I'm going to use my volume calculation tool now to calculate the volume between that plane and the retaining wall. Just setting a quick resolution for my volume. And I'm picking a plane at that point that I just created, that spill point. And calculating the volume. Now it's giving me the volume overall with this plane compared to the retaining wall. So I'm just going to go through now and segment around the inside of the retaining wall where it intersects with that plane so I get the volume just inside there. Okay, just about done. All right, so now I'm keeping only the volume inside between those, the plane and that mesh. Just display my tank. I'm going to go and segment around and cut out that area from the volume if I want. And I haven't seen any questions on the chat yet, so I hope everybody can hear me and my video is going across. I feel really silly talking to myself for an hour. Feel free to post questions if you have them. Okay, so I've extracted out the tank from the volume. I can create a volume calculation report. It's going to give me a lot of information in addition to the volume, like the area, the surface area. Okay, so I've created my report. Just for an added touch, I'm going to go ahead and add my tank so I can see it visually, do a quick screen snap just using my computer's print screen abilities, and then just add that image into my report so everybody can quickly see what's there. Okay, so well, must be getting good at this. Every time I do this, I end up with exactly 5 minutes left. So 5 minutes left for any questions that you might have. You can go ahead and type them into the chat box. What I've got here is the tank calibration tool. I'm just going to skip this for the sake of time. There are videos posted on this. If you go to YouTube, Hi everyone.
Что это было?